Good morning, students. Myself Rupa from Pramati Hillview Academy. In previous class, you had studied about refraction of light, formation of images by lenses, some effects of refraction of light. In today's class, you will be learning about prism, refraction of light through prism, dispersion of light by prism, and few of its applications. A prism is a transparent refracting medium bounded by two plane surfaces inclined at some angle. The plane surface through which light passes is called the refracting surface. Now look at this picture. Here triangle ABC is the principal section of the prism and angle BAC is the angle of the prism. So here you can see the angle of the prism is denoted by angle A. Now A, B, E, D and A, C, F, D. They are known as the two refracting surfaces and line AD is the refracting edge and the surface BCFE is the base of the prism which is usually grounded. The line of intersection of the two surfaces is called the refracting edge of the prism and the section of prism perpendicular to the refracting edge is called the principal section of the prism. See here the principal section ABC of a prism is shown here and angle A is the angle of the prism or we can say angle BAC is the angle of prism. A monochromatic ray of light PQ. Monochromatic ray means a ray of light having single wavelength or we can say a single color ray of light. So what happens when a monochromatic ray of light which is PQ incident on the face AB at an angle of incidence I1, it undergoes refraction because it goes from rarer medium to denser medium. Here you have air and here you have glass. So it suffers refraction at face AB. So it bends towards the normal Qn making an angle of refraction equal to R1 and travels along QR inside the prism. Thus QR is the refracted ray. The refracted ray QR strikes the surface AC of the prism at an angle of R2. It surface refraction from glass which is denser medium to air here which is rarer medium at face AC. So it bends away from normal Rn2 and emerges out of the prism Rs at an angle of emergence I2. So now here we call it as an emergent ray. So RS is the emergent ray. The ray of light suffers refraction at two faces. Which are the two faces? AB and AC. So you can see here the incident ray bends towards the normal as it undergoes refraction because it travels from rarer medium to denser medium and as it travels along again it suffers refraction because here one more face of the prism that is AC is there and it bends away from the normal but towards the base of the prism. In the absence of prism, the incident ray PQ would have travelled along PQML. The emergent ray RS appears to be coming along MRS. The angle LMR, which is the angle between the incident ray PQ produced forward and emergent RS produced backward, is called the angle of deviation. So this delta, it is known as angle of deviation and it is denoted by delta. The value of the angle of deviation or the deviation produced by a prism depends on following factors. They are the angle of incidence, the material of the prism, the angle of the prism and the wavelength of the light used or we can say the color of the light. In the year 1665, Newton discovered by his experiment with glass prism that white light consists of a mixture of 7 colors. Newton found that even when white light, that is example sunlight or light from electric bulb, is made to fall on one face of a glass prism, it is observed that in addition to the bending, there is a distinct separation of white light into 7 colors. This is because each color undergoes refraction according to the law of refraction and moves in different directions. The process of splitting up of a white light into its constituent colors as it passes through a refracting medium is known as dispersion. So the different colors obtained constitute the spectrum of incident light. In this slide, I'll show you that how white light is a mixture of 7 colors. Sunlight or any arc of light after passing through a narrow slit in a dark room which is made incident on one of the refracting faces of the prism. So AB is the refracting face of the prism. So when it is made incident on one of the refracting faces of prism, the light emerging from the prism consists of 7 constituent colors, namely violet, indigo, blue, green, yellow, orange and red. The color band which is obtained here is called spectrum. In case of sunlight, the solar spectrum obtained can be remembered by the word Vibgyor, formed by the initial letters of the colors, that is V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange and R for red. It may be noted out that these colors, red is the least deviated. Observe here, I am showing red is the least deviated and violet is the most deviated. Let us learn the cause of dispersion of light. White light consists of 7 colors as we have discussed earlier. It consists of 7 colors, that is red, orange, yellow, green, blue, indigo and violet. Each color has its own wavelength. The wavelength of red color is longest. You can see here, which is the least deviated one, but the wavelength is the longest, and wavelength of violet color of light is the shortest. The speed of light depends upon the wavelength or color of light. If wavelength of a color is large, the speed of the color is also large. Thus, each color of light travels with different speeds in a given medium. The speed of red color is more than the speed of orange color in a medium. The speed of orange color is more than speed of yellow color. So, it goes on like this itself. Therefore, the speed of red color in a medium is the highest and the speed of violet color is the least. So, all colors of white light are refracted by different amounts while passing through the glass prism. Therefore, when a white light passes through a glass prism, different constituent colors come out of the prism at different angles. Observe this. It comes out at different angles, gives rise to the dispersion of white light. We have seen that white light is dispersed into its 7 color components by a prism. Can we recombine these 7 colors to obtain white light? Now let us see here. Take 2 glass prisms of same material and of same refracting angle. Keep the second prism upside down with respect to the first prism. See here, the second prism, that is P dash, Q dash, R dash, is kept upside down with respect to the first prism, that is P, Q, R. Allow a narrow beam of light or white light to fall on the first prism. What happens? The first prism here, it splits up into 7 constituent colors or 7 color components. When these color components fall on the second prism, here we have taken inverted prism. So when these 7 component colors fall on this inverted prism, it recombines them into white light, which is here obtained on the screen. So white light is obtained. From this, we can conclude that we can recombine these 7 colors to obtain white light. You might have seen a beautiful rainbow in the sky after rainfall. This rainbow is formed due to dispersion of sunlight. When sunlight falls on water drops suspended in the atmosphere after rainfall, rainbow is formed due to the dispersion of sunlight. The water drops suspended in air here or in atmosphere, it acts as a prism. So we can say rainbow is an example of dispersion of sunlight. Let us learn the formation of rainbow after rainfall. When sunlight falls on water drops suspended in air, then the sunlight is refracted. The refracted sunlight splits into its 7 constituent colors. So water drops suspended in air behaves as a glass prism. This part, it acts as a glass prism, and when sunlight falls on this water droplets, it gets refracted and splits up into 7 constituent colors. The red color deviates the least and the violet color deviates the most. Different colors of refracted sunlight falls on the opposite face of the water drop. You can see here, each color suffers internal reflection. The reflected colors on reaching the lower surface of the water drop are refracted again into the air. So we get a spectrum of 7 colors, which is known as rainbow. There are 2 types of rainbows. One is primary rainbow and the other one is known as the secondary rainbow. In primary rainbow, the outer arc is red and the inner arc is violet. The other colors are mixed up and lie in between 2 extreme colors, that is in between red and violet. The primary rainbow is the result of one internal reflection. The secondary rainbow is produced by 2 internal reflections. Hence, therefore, the orders of colors is reversed here. The outer arc is violet and the inner arc is red. The secondary rainbow is quite faint as most of the energy is lost in 2 reflections. Children, in today's session, you have studied about prism and refraction of light in prism, dispersion of light by a prism and cause of dispersion, formation of rainbow. Thank you.